These are V-folds, one of the most fundamental pop-up shapes. A right-angled V-fold, an acute-angled V-fold, and an acute-angled V-fold. And the name of the angles is, it's the angle between that fold and that fold. There are some V-fold variants, pointed V-fold, an asymmetric V-fold, and here is a V-fold with some counterfolds built into the ridge and into the gully. This is the other big fundamental fold, parallel fold, symmetric parallel fold, an asymmetric parallel fold. And at the bottom we've got a symmetric parallel fold which is raising an obtuse angled V-fold on its ridge. These are variants on the parallel fold. So here we've taken a parallel fold and glued together the top of it so that we get a sort of spine. Here we haven't creased along the bottom there, so we end up with a curve. And this combines the two, where we have the curve and the glued spine at the top. And here's an asymmetric V-fold in the curved form. These yellow pieces are parallelograms built into gullies that open up to right angles, so not like the main gully which opens up flat. And the key point about this and all pop-ups is where the creases and the ridges are. What joins them doesn't matter so much, so we can make them with rectangular faces like this one or parallelograms like that one. These are zigzag folds, which look very confusing, but I think you can probably understand them as a V-fold with its apex replaced by another V-fold going the other way. So this mechanically is like a complete V-fold with a parallel fold glued into its gully. And these are all made of the same piece, just glued onto the paper in different ways. Here are some zigzag fold variants with angled folds, angled inwards or outwards or asymmetric. Even more confusing, the M fold. These are floating planes. This floating plane is raised on a parallel fold and also some parallelograms. This one is off centre, this one is raised on an asymmetric base, and so we get a non-parallel floating plane. These are floating planes raised on V-folds. They have this rather nice property that in the final phase of opening they kind of present themselves forward. And this bottom one here is 3 stacked floating planes on top of each other, so you can get quite a lot of height. This is a cubical box. You have to pay great attention to the length of this piece. This one is a tiny bit too long because I didn't think about the thickness of the cardboard, so it sticks out a bit. Here are some open top shapes. This one is based on a parallel fold in that it's glued there and there. Likewise, that one and that one. This one is based on a V-fold that's glued there and there. And these shapes can be smooth or they can be faceted. There are some pyramids. The top one and the middle one are based on a V-fold. It's glued there and there. That's what provides the action. And this is another piece. Well, it's the same piece, but in effect it's another piece attached to that V-fold. This one is based on a parallel fold. It's glued there and there. There are some variants on pyramids: asymmetric pyramid, cone, and an elongated pyramid. There are some curved shapes raised, in this case on a parallel fold, but here on a V fold, and here also on a V fold. Twisting mechanism. It's very intriguing. It's also a bit puzzling. These twisting mechanisms have got a pop to them. Sometimes you build them and they don't, and I've never worked out what aspect of the geometry causes the pop to be there or not. These are automatic pull strips. The strips are attached to the left-hand page and they raise or rotate things on the right-hand page as they come up, as they get pulled. Here are some moving arms. These are based on a fundamental parallelogram mechanism, but with a counterfold. Is that a counterfold? Anyway, a V-fold in there. Very, very difficult to understand what's going on, but you can get some nice things going on, including basically a pure rotation, or something close to a pure rotation. And here are some more variants on moving arms. A bit of trouble with the one in the middle.